So these are the units and the concepts that we covered. If you want to write this down, great. I'm going to kind of quickly go over it and then I'll put it on this front desk if you want to take a picture of it on your way out of class today. But in unit 1 is when we obviously started with what a function is. We talked about and learned functional notation. What's ARC? Average rate of change, and we learned how to calculate that. We talked about a limiting value, which we'll get into a problem today that has that in it. And then, of course, each unit we introduced calculator usage of how we would answer questions. One of the things that I harped on all semester was being able to identify and define the function and the variable. We've done graphs, tables, and formulas. We have not done tables in a while. We're going to look at one of those today, so you'll want to be practicing on that. And then whether the function is increasing, decreasing, concave up, concave down. We talked about an inflection point. We'll talk about that today. In unit 2, we learned how to create a table. We learned how to create a graph. And then unit 2 is applying everything you learned in unit 1. And then whether you were given the variable function or the, not the variable function, the variable value or the function value and having to find the other one. We looked at intersections and then we looked at finding the minimum and the maximum. We've not done that in a while either. And then in unit 3, we talked about linear functions or linear equations, which brought in slope, which is the same thing as the average rate of change. Then we talked about ordered pairs and remembering that the first number is your variable, the second one is your function. The linear equation model, which is y equals mx plus b, y being your function, m being your average rate of change or slope, x being your variable, and b being your initial value, which is also known as the y-intercept, which linear functions have a constant rate of change. And we had to show that from a table. I don't know if you remember that, to show that they have the exact same rate of change. And then the linear regression equation. And then, of course, the last unit, which we just got out of, which was exponential functions. And so all of the things that you guys were just tested on right before Thanksgiving. So these are the things that we're going to be reminding ourselves of. And so again, if you want to take a picture of that on your way out. Some of the things we're going to look at today, we haven't done on the calculator in a while. So of course you've got your calculator instructions that you can always refer to. But one of the things that I would highly recommend in preparing for this final exam is really working on making sure that those calculator skills, that if you've kind of lost them, that you can get them back. And some of them we haven't done in a while. Okay. All right. So again, this is found in Blackboard. Under content, there was a final unit, and this is where those are found. So again, if you did not get that printed off, please do so before class on Wednesday. Okay, so also notice that it tells you what units and sections these chapters and sections these can be found in. That's helpful if you're reworking this and you want to go back to your notes and see where this is found. Okay, so we're just going to start in the chapter 2 information. Okay, a conservation organization releases animals of an endangered species into a game preserve. The organization believes that the growth of the herd will be modeled by the function P equals, so here's your equation, it starts out here and ends here, where P is the population of the animals and T is the time in months since the animals were introduced to the preserve. Okay, so this particular question, and some of these aren't asking it, but I'm going to continue to do so, and that is defining the function and the variable. Okay. So what letter is used for your function in this one? P. So once I establish that, then it says P is population of animals. All right, so that means T has to be my variable, and that is time in months since they were introduced to the preserve. So I'm going to say months since introduced. Now, that's helpful then as we go because it helps me to label things or answer questions if I have those defined appropriately. Okay, so the first question is asking us to make a table. Okay, this is something we have not done in a while. So our calculator steps, so if we're going to go to our calculator, what do you recall, or what might be your best guess on what we would do first? We have to put in the equation, right? We were given an equation, so the first thing that I'm going to do is y1 equals, and I'm going to enter that equation that was given. All right, so I'm going to go to y equals, oh, mine's already in there, but let's pretend it wasn't. Okay, so to get to the fractional, alpha y equals 1. The numerator is 1200 and the denominator is 1 plus 9. E is second natural log. And then that exponent is negative 0.1756 t, and so that'll be my x. All right, so I've got y equals in there. Now it says make a table for the population of the animals at, and we're given this information right here as well. So that's going to help me with step 2, which what is step 2? Table set. All right, so table set is above window. So it is second window. Do this if you need to, whoops. Window, which is table set. And then it wants where we start. So where would we start at?
0.
0. And then the triangle means the change in the table. And what are they counting by? Well, so mine are already set. I'm going to guess yours aren't. So once I get the table set in, what is the last step? Table, which is second graph. All right, so there's my table. Okay, now when I make this table, what always goes on top? The variable. So I have that listed here. So T is months. And then function is P, which is population of animals. And I know my variable, I did 0, 12, 24, and 36. So that is my variable, which is this first column. So I'm going to come over here to the second column. So I would get 120. And then 573.01. 1059.1, and then 1180.9. Now, obviously the table continues, but this just told me to go to 36 months, so that's all I would be looking for. Everybody good on their calculator? We haven't done that one in a while. Okay, make a graph of P versus T for the first 36 months. All right, y'all, what is something that I'm going to harp on that I have said over and over and over again? Don't forget to do it on tests, and yet I still have some forget to do it. Label your axes, okay? So the vertical one, the one that goes up and down, is that your function or variable? function, so that's gonna be P population of animals. And then my variables, the horizontal, which is months since introduced. Okay, so if we're talking about calculator instructions for this, well, of course, first is be sure your equation's in there, which ours is already. So now what would be my second step? Window. All right, so when you hit window, it wants your X minimum, which is your variable minimum. So what did we start with? 0, and what was the maximum we want to be concerned with? 36. No, mine's 37. And then what's the last step? Nope. Zoom 0. You can't hit graph until you've at least done zoom 0. And that will get us our graph. All right, so something like that-ish. Okay, after how many months will the population be 600? What's given? Function value. So am I going to come up here to my equation and where the t is, am I going to put 600? No, that's your variable. We're given the function value, which is p. So in place of the p, we'll put 600. And that's equal to the equation 1200 over 1 plus 9e to the negative 0.1756 t. This is already in our calculator as y1. What are we going to do with 600? Yeah, that becomes our y2, because ultimately when I go to y2 and I put in 600, what am I looking for?
Intersection.
And where is intersection found? So we put in y1 and y2. What'd you say?
Second.
Okay. Second calc, which is trace. So second trace, which is calc. And then we're going to hit, is it 5?
Yeah.
Okay. This is where, if you recall, so pay attention to that cursor is at, it's not on the intersection, it's on one of the curves. So first curve, enter, second curve, enter, guess, enter, and then you're given X and Y. Well, Y is the 600 that we already put in for our Y2, correct? So we're looking for X, but in our case, X is what letter? T. And I'm going to go 2 decimals, 12.51 what? Months. Okay, over what time period is the graph concave up? Okay, so go back to, we don't need the horizontal. So I'm going to go back to y equal, and I'm going to get rid of the 600 equation. And then I'm going to do zoom 0. and get back to my equation. All right, so it's asking when it is concave up. Okay, so remembering concavity with cups up or cups down, what does my graph start out as? Does it start out as concave up or down? Up, and then it becomes concave down. So there's a particular point somewhere in here where the concavity changes, right? Okay, what's that called? Inflection point. All right, so it says over what time period, and time period is your horizontal axis, is the graph concave up. So we're talking about from here to here, okay? So it's concave up from 0 months, and then we've got to get an approximation for this, okay? So what I would do is look at this and go, okay, about right here is where I would kind of guesstimate that my concavity changes. So I'm going to hit trace, and then I want to move my cursor to about there. So I would say anywhere from 14 to 15 months, somewhere in there. So again, that's going to be an approximation. I don't know if you remember on that test, I gave some leeway on that. So I'm going to say from 0 to, I'm going to say 14 months. But again, that could have some flexibility in that. 0 to 2 months, no, that's wrong. Okay. All right, then it asks us to explain what that means. Okay, so on the explanation, remember, we're always explaining what the function is doing. And our function is population of animals. So I'm going to start out and just say the population of animals is, now we're only describing this concave up section right here. So what is this function doing? It is increasing at what rate? Increasing rate. Now, if we were describing the whole function, we would say it's increasing at a decreasing rate, but we're only describing this portion of it. Now, what is significant about the inflection point? What does that tell us about the function?
That's changing.
It does change concavity, but there's something that's going on at this point. It's doing something the most at that point. Either increasing or decreasing. So in this one, since it's going up, at the inflection point is where it is increasing most rapidly, or the population of the animals is growing the fastest at that inflection point. If this was something where it was one that went down, then that's where it's decreasing most rapidly. Okay, so that fits into question 5. At what time was the population increasing the fastest? So this is basically asking you, where is the inflection point? And we said what, approximately 14 months? Okay, what is the limiting value? So we can look in this graph, and as this begins to level out, we know we have a limiting value here. Where do we go to find that? The table. And that's second graph. I'm gonna go back to and do second graph, which is table. And then I'm gonna come here and look at my output and it very quickly becomes, what's my limiting value? 1,200 what? Animals. All right. Find the average rate of increase in the population from 12 to 24 months and then explain. Okay, so we're gonna find the average rate of increase or the average rate of change from 12 to 24. Okay, what's that formula? It's what over what?
Change in function of the change.
Exactly right. Change in function over change in variable. And we're doing 12 to 24. So I'm going to come back up here. Here's my 12 and my 24. And remember, we pull and we go backwards when we do that subtraction. So we have 1,059.1 minus 573.01. 24 minus 12. And we want this over 1. Alpha y equals 1. 1059.1 minus 573.01 over 24 minus 12. So I'm going to go 2 decimal places, so 40.51. All right, so to help me with the explain, I'm going to label this. So my numerator or on top is the change in the function. So 40.51 represents what? Animals. Per one what? Month. So again, when we go to explain, we're talking about the population of animals. From 12 to 24 months is, and what is it doing? Increasing. Now, it had the word increase here, but if it didn't have that word increase there, how would I know that this is increasing? It's a positive number. So it is increasing 40.51 animals per 1 month, or just per month, you could put. All right. 2.6. All right, a grapefruit was catapulted straight up in the air. Its height at time t is given by, so we're given our equation here, which tells me h is the function and t is the variable. So h is the height in feet and t is the time in seconds. So hopefully that doesn't take you long to find. So h is height, feet, variable is t, which is in seconds. All right. So make a graph. Okay, so first off, h is my function, so that is height. That's in feet. Variable t, and that's in seconds. All right. So in your calculator, what's step 1? Y1. We're given an equation, so I'm going to go do that first. Which means I'm going to clear out what I've got. Negative 16x squared plus 100.3 x plus 4.1. Okay. Pay attention to this because what is that going to help me with? Yeah, I'm going to go to the window. It wants the x minimum, which the first 7 seconds, so that would be 0 to 7, and then zoom 0. So if you're having any calculator problems, now's the time to be asking. Notice it does not start in the corner. Does that make sense, right? We're chunking a grapefruit. Am I gonna lay on the ground and throw it from the very corner? No, I'm standing up. So it is going to go up, and then of course what goes up must come down. This is 7 seconds right here. Hits the ground. Okay. When did the grapefruit reach its maximum height? When did it reach the maximum height? Okay. Before we look at this, I want you to think in terms of an ordered pair. Variable is always first, and our variable is t, so this is seconds. Function is always second, which is h, which is height, which is in feet. Okay. All right, so we've already got our, so in the calculator, we've already got our y1 equals. So to find the maximum, where do I go? Second trace. That is calc. So second trace calc, and we're going to do 5. Okay. Oh, 4. I was gonna say that's not right. Sorry about that. I was doing intersection. Okay, now remember when you do what we want is the maximum, which is the top of the hill, right? And so it always comes out first and it says left bound. That means that your cursor has to be to the left of the top of the hill. So just move your cursor somewhere till you know that it's to the left of the top of the hill, hit enter. And now it wants me to go right bound. I'm going to move my cursor over. Looks like it's right there. Hit enter, and then it's going to do a guess and then hit enter. So then you're going to get 2 numbers. You're going to get x equals 3.13, and you're going to get y equals 161.29. Now, this is where you've got to know which is your variable and which is your function. Variable is x, function is y. This says, when did the grapefruit reach this? So is it asking for the 3.13 or the 161.29? This is my variable t, which is 3.13 seconds. A when is a time question. So that's what's being asked in 9. 10 says, what is the maximum height of the grapefruit? Height is our function, which is 161.29 what? Feet. So we found that, but it didn't ask for it until 10. So you got to be sure that you know what it's asking and Don't give me both answers on 9 and not specify which one's your answer. Now, I will say that there'll probably be a lot of multiple choice questions on the final. And you know, rounding is important because this was 161.288. So there'll probably be a 161.28 option on there. So be careful with your rounding. Also pay attention to if it says rounded 2 decimal places or 3 decimal places. So be careful of that. Okay. Net income is a linear function of total sales. Well, right there, it's telling me what my function is and what my variable is. So I'm going to write that over here. So my function, net income, so I'm going to call it N. And then my variable, total sales, I'm going to do lowercase t, and that'll be total sales. Now, linear is important here, so pay attention to the fact that it's saying it's linear, because that'll come into play with some of the work that we have to do. Okay, during the month of July, a real estate agency had total sales of $832,000 and showed a net income of $15,704. In August, total sales were $326,000 with a net income of only $523. Okay, so notice they are not giving us an equation. What are they giving us? No, we'll have to find that. They didn't give it to us.
What is the function in variables?
What are those numbers called? Because they're giving us information for July. And then they're giving us information about August. They are, for July, they are giving us total sales number and they're giving us a net income number. How can I pair those numbers together? What is that called? Creating a what? Ordered pair. So remember, in your ordered pair, variable goes first, function goes second. Don't assume that your numbers are in the correct order. Okay, so for July, we want total sales first, which was 832,000. And net income 15,704. And then for August, we were given 326,000 total sales and a net income of 523. So we're given 2 ordered pairs. Now, here it asks us to calculate the slope. Well, you're going to have to remember that this is called X1, Y1, and this is called X2, Y2, because, and notice this is in section 3.2, we were given a slope formula. So the slope formula, which is, the slope is the same thing as the average rate of change. We're going to have to calculate it. Does anybody remember that formula? Y2 minus Y1 over X2 minus X1. So your slope is Y2 minus Y1, which y'all, that's the change in the function, over X2 minus X1, which is your change in the variable. So we've got 523 minus 15,704 over 326,000 minus 832,000. And this is going to give me something over 1. I'm going to let you guys calculate it and tell me. They get it?
0.03.
0.3. Okay, so my numerator is my function, so this is net income. My denominator is the variable, which is total sales. And this right here is your slope. And it's positive, so we know it's increasing. Okay, what else did it ask us to find? Initial value. Okay, this is where you need to recall. So let me write this. Initial value is what we're looking for here. Sorry, I'm running out of room, so I'm having to write a little smaller. I'll zoom it in more so you can see. Okay, initial value. Okay, this is where knowing this is a linear function is important. So what is our linear equation model?
Y MX plus B.
Y equals mx plus b. Okay, well, what part of that linear equation did we just find? Slope, right? So we know this right here, we know is 0.03. What letter represents the initial value? B. So I need to find out what B is. It's not given because I don't have anything that has a variable of 0. So what am I going to have to do in order to find a B? I have to plug in. Look at your ordered pairs. Here's an X and a Y, here's an X and a Y. It doesn't matter which one you use. I'll go ahead and just use the first one. So in place of Y, I'm going to put 15,704. And then in place of M, I'm putting 0.03 times X, 832,000 plus B. So I have 15,704 equals, so now I'm going to take 0.03 times 832,000. And I get 24,960. Okay, so now I need to solve this equation for B. So how do I get rid of this number?
I'm sorry, I catch that. Could you please say that again?
I'll say it louder if you need me to. All right, so I'm going to get rid of this number by subtracting it. 24,960. So what do you get when you subtract those? Is it negative? Yeah, would you say negative what? Okay, so this is your initial value. Okay, now these are the two things that we need in 12 where it says write an equation for n as a linear function of the total sales t. Now notice t is capitalized. We did lowercase. That's fine. We're just going to leave it lowercase. Okay, so again, it's a linear equation which we know originates from y equals mx plus b. Y is my function. We called the function what? N. Slope, you told me correctly, that's 0.03. My variable is not X, but is T. So whether you use lower or capital, it doesn't matter. And then in place of B, what am I going to put? Negative. So I'm going to do minus 9,256. And then, of course, that equation is going to be needed for number 13 that says if the net income is 10,000, what were the total sales? Okay, what was given? Okay, so if 10,000 is my function value, it goes in place of N. Now, your variable has a coefficient of 1, not a coefficient, sorry, has an exponent of 1, right? So if we want to know what t is, if it is to the first power, then I don't have to go to my calculator. What do? I just take this equation and do what? Solve for t. Okay, so if I want t by itself, I first have to get this term by itself. So how do I move minus 9,256? I'm gonna add it. And then 0.03 and t are being multiplied. How do we undo multiplication? Divide, so we're gonna divide both sides by 0.03. Whoops. Is that what you guys got?
Yeah.
Okay, we're talking money. So 641,866.67 cents.
Total sales.
Right. Which total sales is in dollar amount. But you are correct because net income is in. Because see, your total sales was money value, not number of items. Is that where you, yeah,
I was confused.
yeah, and it could be either, so you have to go back up to see what they were giving us, and they were giving us total sale money value, not item numbers, okay? All right, so we are gonna stop there, because that's where I got on my last class. Let me